he is certainly neurodivergent. He's been diagnosed with dyspraxia as well. So throughout his childhood, if I wanted him to do something, it'd be like, Jamie, look into my eyes. I want you to go to the shop to buy some ice. And he would come back with ice cream. So it's amazing to think that he's now, of course it's a vocational thing, right? You know, driving a digger. You can't do that if you're AI. I don't know if you've seen this. I expect probably everyone is going to go from this keynote and register with this site. This is the way that we make money now. It's rent a human. So we can now all just give our body to AI, and then they'll send us a message and they'll start to use us and they'll probably pay us some. This is the future, guys, this is the future. But some people talk about ADHD and neurodiversity as a superpower, and that's another thing that I've been thinking a lot about. Because on one hand, it is a superpower. It allows us to think creatively and think out of the box and spot patterns. And I think these are the things that perhaps that quote was talking about, the creativity that comes from that diversity. But of course, on the other hand, it's quite challenging sometimes. I can find it very, very difficult to live with an ADHD brain, because it does some very strange things to me sometimes. I'm trying to do things and suddenly something will pop into my head and it will go down a rabbit hole, and then I've got time blindness and hours can pass. Has anyone experienced this? This time blindness is like, ooh, that looks interesting. I'm just going to scratch that a little bit, and then and then suddenly, yeah, it's dark outside. Oh, it is morning. Now, of course, in IT, that's a really, really useful thing, right? So it's both a superpower and also quite challenging if you're trying to do your timesheet that needs to be in by 5 o'clock. I learned about ADHD from my daughter, and she really struggles. She really does. She's at university at the moment studying biology, and she finds it incredibly difficult to get all of the things done on time because she gets overwhelmed. There's this complete noise of all the things in her head, all this wanting to go down rabbit holes. And I feel for her, and I want to help her, but I can't really do anything, because you can't say to her, well, what you need to do is plan better. Write a list. That'll work. A checklist. That's not good. Anyone who suffers with this kind of challenge knows, and actually just me saying that because I'm her dad, that's just going to make her fly off the handle. So she's actually been taking medication, ADHD medication, but she's been really worried, like, but what if I take these meds, what if I lose my sparkle? Because she's got a beautiful sparkle. They're going down rabbit holes, they're going off crazy, we mess around, we goof around, dance in the kitchen. But, you know, I kind of... I think I saw this guy in Hamburg, actually. So I thought, do you want to join me down a rabbit hole?
Yeah.
Yeah? Is that a good thing? I mean, I know that we're going to go to the party afterwards, right? But, you know, do you want to join me? I mean, it could get dark, depending... So keep me on track here, right? Keep me on track. So, this happened a few days ago. So I was thinking about GitHub Copilot, which I love. So if you don't use GitHub Copilot, if you're using Claude, use GitHub Copilot, please, because it's one of my metrics. I work for Microsoft. Just say that you do, okay, if anyone asks. It's amazing. GitHub Copilot allows me to do amazing things. It also allows me to do things in the cloud. So I can start something on my desktop, building some code, building whatever, or even just using it to build some PowerPoint decks. I didn't use it to create this PowerPoint deck, honestly. But I would then start, and then I can say, well, actually, I'm going to go, to the gym or on a walk, and I just send that into the cloud, and it will carry on in the cloud, so it's unattended. Now, OpenClaw is kind of a similar thing. You can actually have OpenClaw running on a machine, and you can talk to it through WhatsApp or through Slack and give it tasks to do, and then it will use tools. It can use all the tools on your desktop. So it's like an autonomous thing. It's really very, very productive. So I was thinking about this because this thing, I mean, it always reminds me of AJ. So YOLO, right? I mean, imagine giving AJ access to all of your stuff on your desktop. What's the worst that could happen? I mean,
Nothing.
be fine. That's the idea of open clause. Just think about it as giving AJ your email box. But YOLO, you only live once. And this is a mode that you can put these AI agents into where they just do stuff without asking your permission. So I was thinking about, like, you know, it feels bad, but it feels good. Kind of like AJ. But then there's a new feature in GitHub Copilot called Autopilot. Now, Autopilot is basically taking YOLO mode and going, you know, YOLO mode, probably not a good name for an enterprise system. So we probably need to come up with some. We've got Copilot, so let's just use Autopilot. So what Autopilot does is it just basically tries to kind of just, you know, keep AJ in check, make sure that he's not doing anything that he shouldn't be doing, occasionally checking in. I use Autopilot all the time, so I'll go to bed and let my agents cook. If those of you who are in my workshop a couple of days ago will know that my favorite prompt is go cook. Okay, so I want to hear everyone on LinkedIn, on X, wherever you are, just saying, oh yeah, I just told my agent to go cook, and it did this thing. So really easy to type, very satisfying to press return, go cook. But Autopilot, the logo is a rocket. This is what my brain does. Oh, rocket. Oh yeah, Artemis 2. Anyone heard about Artemis 2 in the news? Yeah? Anyone? No? Yeah, right, okay, yeah. It's a rocket that's just going around the moon. Yeah. There's crazy things happening in the world. Yeah, a rocket that can go down further than any rocket has kind of been with a human on board into space. Well, you know, that's just a sign of the times, right? That's the time that we're going to this. But then, so we had like Apollo 11, which they kind of landed on the moon, you know, one small step for man, one great leap for mankind, that kind of thing. And then we had Artemis 2 with this quote. Never ever gonna let them forget that. The Outlook team must be really pissed. They really, I mean, although they do say there's no such thing as bad publicity, right? But then I'm not so sure, especially if it's going to be remembered like the original Neil Armstrong quote. But you know, it is amazing that we can send these things into space. And I was looking at the difference between the two different trajectories of the Apollo 8, which is the Apollo 8 mission, was the one that they tried out to go around the moon, which is basically what Artemis 2 was doing. Before landing on the moon, they're just trying out the retro rockets. And it's amazing, actually. I got my daughter to explain this to me because I didn't quite work it out, but the way that the perspectives kind of shift. And actually, the Artemis 2, the trajectory is incredible. The calculations that's been used to do this, to get like the minimum fuel, and it uses all the gravitational fields. The math is insane on how it works. And then I thought, I went further down the rabbit hole. I went, so did they use AI to build that stuff? Did they use AI to build the control system for Artemis 2? I don't see any reason not to. I mean, AI now writes 30% of code at Microsoft and Google, and so, you know, 100% apparently of Claude code's AI code is written in AI, so why not Artemis 2? I mean, what's the worst that could happen, right? No, actually, that was Apollo 13. And so Apollo 11, they had a 1202 alarm, okay? 1202 during the mission. It was actually just at the point where they were starting to approach the lunar landing module.
Okay, all selected colors, go for landing. Retro. Go. Rhino. Go. Guide. Go. Control. Go. Telcom. Go. GNC. Go. Ecom. Go. Surgeon. Go. Capcom, we're go for landing. Altitude 4200. Configure go for landing, over. 1201. 1201. Roger, 1201 alarm. 1201 alarm. Stand by for go flight. Give us a reading on the 1202 program. We're going that flight. We're going that alarm. Roger, we got you. We're going that alarm. We go. Roger. He's taking in the station now. Roger. 40 feet down, 2.5. Picking up some dust. Straight shadow. 4 forward, drifting to the right level. 30 seconds forward. Contact light. Tranquility Base here. The Eagle has landed. Roger, Tranquility. We copy you on the ground. You got a bunch of guys about to turn blue. We're breathing again. Tranquilize.
That's chilling, right? It's crazy to think that that can happen all that time ago as well. And this is the transcript that actually happened. So they're in the lunar module. This alarm lights up. 1201, 1202. And that gets sent back to mission control. Roger, 1201 alarm. Now, in the back room, there was a guy called Jack Garman, who you will find very little mention of in any of the reports about this mission. But he was the guy that looked through what was coming back from that sensor, from those alarms, and he knew that system back to front. He knew it inside out. He knew exactly what was going on. And so quickly he said, it's okay, we're good. You didn't hear it. No one heard that on the public broadcast. But then Steve Bales, who he's in Guido, right? So Guido is one of the departments, one of the units that actually manage all the different parts of the mission. So Guido says, we go, because Jack told him. And then the flight director says, continue. And then Charlie Duke on Capcom, we go. Same type, we go. They knew what it was. So they carried on. Now, if Jack had made the wrong decision, I don't even want to think about what would happen. But Jack knew exactly what was going on. And actually, what was happening is the navigation, or the radar that was giving them the feedback from the distance between where they were and where the moon was flooding the computer system. The computer system was a very early multi-threading system. It had one processor. None of this multi-core stuff we get today. It has one processor. And it had so many different programs all running, taking data in from all these different sensors. Really complex stuff. And what it would do is it had a very small amount of memory to run these programs. And it would start at one address and it would move to the next and then it would process that and it would move to the next and process that in its small little bit of memory. And there was a particular bit of programming which was responsible to finding a spare space to run the program that needed to be run next. And you wouldn't notice it was running so quickly that it looked like it was all running at the same time. What was happening is the system was flooding it with requests to run these programs, and it was running out of space. And that's what the 1201 and 1202 alarms were. It had run out of space, it couldn't run any more programs. And so Jack knew that was okay, because what happened is it reboots. It goes, okay, clear the memory, run another program. So they knew that was going to be okay, because it would be fault tolerant. So I thought, okay, I know I've got to get my timesheet in, but I thought, can I go and look at the code? I've never seen this code. So I go up onto GitHub, and lo and behold, the Apollo 11 code is on GitHub. It's so cool, you can go there, go and search for it. It's written in this language called, it's called the Apollo Guidance Computer Assembly Language, AGC. Okay, and it's a dedicated computer language which was written specifically for Apollo. Okay, and you can actually see all these different assembly language which get compiled down into machine code. This is the stuff that I used to do when I first started programming. I used to program in assembly language. Admittedly not AGC, but still. Anyway, a little bit further down the rabbit hole, I found the GitHub issue. Error 1201 and 1202. Someone's logged an issue saying, oh, there's a bug in the program. You need to fix it. NASA then subsequently commented and said, status won't fix. So they decided to not fix it. Now, I thought, okay, just, you're good with me? You with me so far? You still with me? Everyone with me at the back? Yeah? You're not falling asleep? I know it's been a long day, and our brains are full. So hopefully, you can just see where I'm going. So I thought, what about if vibe coding is such a cool thing, if AI is so good at fixing code, I bet that AI has got real knowledge of AGC. I bet it's very little training on Apollo Guidance Computer Assembly Language. Let's see if it can fix this bug. So I went into GitHub Copilot, CLI, cloned the Apollo 11 repo, and analyzed issue 23. So what it does is it goes off, okay, and it looks at issue 23. It clones the repo, brings it down, then it reads the AGC source. And it starts to interpret it and starts to learn about how it works. And, okay, so it's found the issue 23, and it said, okay, it reports alarms 1201 and 1202 during a powered descent. The root cause is the rendezvous, radar task, etc. So I just said fix it. I should have said good go cook, shouldn't I? So it goes off and it starts to look at how this works. And it's added some guard checks to suppress rendezvous radar processing during powered descents. It's modified two files, that program AGC, and another lead-in routine. I did take a look at them, and 3 or 4 hours later, I said, well, okay, are there any other PRs, the pull requests that have already fixed this? Because I was interested, maybe someone else has done the same thing. Maybe I'm not the first person to do this. But it didn't find any PRs, didn't find anyone else fixing this. But what it did say, it said, oh yeah, issue 23 was closed as won't fix with a humor label. No implementation has been attempted in this repository. For context, NASA addressed this in a later luminary build used on Apollo 12. So it's now found that actually this bug was fixed in the next mission, which is a good thing, I think. But I just said, well, how did you know that? Because there's nothing in the repo about that, so how did you know that? Now, this might be a familiar situation for you, where it starts to go, oh, hang on a minute, I've been questioned. Maybe they know more than I do. I need to start to explain why I'm doing these things. Oh, and then it just says, I should correct myself. That claim was based on general training data, not evidence from this repository. So I said, okay, well, let's go and find the source, because we've got the Apollo 11 source. Maybe Apollo 12 source is there as well. Maybe. So I said, now this is what's so cool about GitHub Copilot, is that you really just start to get, it is perfect for my rabbit holing. This is fueling my ADHD right here. And so it said, it's found it. It went off and found and cloned the repo of all and it says, yes, the difference is a 7-line addition. And then it gives some information, and then it says, prevent memory cycle snatching by manic RRCDUs. That's actually a comment in the comment made by the engineer who fixed this bug, which is insane to see this, that's been done so long ago. And I said, well, okay, we've now got the fix made by a real engineer. Why did you suggest something completely different? They've changed one line, essentially. You went off and changed 2 modules. If you've ever used any kind of AI coding, you'll be used to saying, go fix this, and it will say, yeah, I've added 3 lines and I've removed 2,000 lines. What did you remove? Nothing of any importance. So I said, well, why is it different then? What did you do? And it said, okay, right, well, I better go and reevaluate it. And it did it, and it kind of looked at the comparison, and it says, well, actually, I did it wrong. I'm sorry about that. You got it wrong, my bad. It's kind of worrying, but it kind of gave this explanation, very complex explanation. So I said, well, what would have been the impact if you actually had done this? Let's see what the impact was going to be. And it said it modeled the different scenarios and analyzed it, and then came back with a crew safety concern. And rather scarily there, at the end, what does it say? A flag logic error I missed, and a non-zero probability of killing astronauts. Do you see why this is called My Agent is Completely Unhinged? What person describes a bug as a non-zero probability of killing astronauts? So that was where my rabbit hole went. So it's not Italian brain rot. This is actually context rot. Okay, so this is the problem with AI. How are we going to fix this? How do we fix the unhinged nature, the brilliant yet unhinged nature of AI? And that's basically what I've been spending my life doing over the last more hours than I care to mention. I've been really trying to do this because I was thinking, surely there is a way of using this brilliance in a way that I'm normally used to using people, working with people, right? Because it's actually turning out that it's just as neurodivergent as me, and it's fueling my ADHD. I need to control this. I really need to get a handle on this. I saw this actually, agents are so sycophantic. They're just, yay, you found a problem. Oh, I cut you in the wrong place. That's fine. It's a good job you spotted that. Let me try this one more time.
Oh, yes.
So, my son, actually, my youngest son, has found this. So I don't know if anyone's got kids with a screen time on their phone. You know, use screen time, and it kind of sends you requests. So my youngest son is this time he's spamming me with requests for more screen time for Claude. And every time I'm like, why aren't you using GitHub Copilot? And he says, that's because, well, Microsoft own Minecraft and they're not fixing the bugs, so I'm not going to use GitHub Copilot. So apparently I've now got to go to the Minecraft team in Microsoft and tell them to fix the bug that my son found, otherwise he won't use GitHub Copilot. But he's found this problem as well. And have you ever done this thing where, so bear with me, so you start using AI and you kind of start to tell it to do something and you kind of go down a particular, a bit of a thread and you start to ask it about something, it gives you some information and then it comes back with something, so you sort of add something more to your prompt and you edit your prompt and you test it some more and it comes back with something you don't expect and you kind of add some more to your prompt and then you're looking at your prompt and it's like reams and reams and dreams of stuff. And then actually what you do is you delete half of that and try it and it works better than it. Have you ever had that? Mm-hmm. Yeah, me too, exactly. Prompting harder does not work. It's just one of those things that you come up against quite quickly when you use these agents. Now, Margaret Hamilton was one of the lead engineers at MIT who wrote the Apollo guidance computer. That's actually the source code there, printed out. I think I'm going to do that for one of my programs as well. But it turns out they knew a few things, right? There's all of this rich history of computer science. It's actually the things that we don't really want to talk about anymore. It's like, why should we be talking about computer science? AI does it for us. Well, it turns out that actually it's kind of important to make the right decisions when there needs to be a zero chance of astronaut death. So I have a confession, actually. So this is the IT crowd. Everyone's seen the IT crowd, right? Trying to turn it off and on again. Yeah, Roy and his and all the different catchphrases. Now I name my agents. So I name my agents usually of characters in the IT crowd. So I've got Moss and Jen and Roy and yeah. So it makes it easier, right? Because I can start to think about them as people. And it's just easier to think about, who's handling this, who's handling this. I have multiple desktops, and I have Roy on one desktop and Jen on another desktop. So what I do is I say, right, okay, I've got my agents, and I define what my agents are going to do. So I start to define actually exactly how I want them to behave. And then I give them knowledge and skills. And then I give them access to tools. So I don't give all of my agents access to all of my tools. Because if you give your agents access to all of the tools, those agents are going to use all of the tools. So if you want an agent to do database design, don't give them a browser because they're probably going to get sidetracked and ADHD down a rabbit hole and start looking at Apollo 11 code. Yeah. So keep the tools away from the people that don't need them. And make sure that the skills that they have are relevant for the things they're doing. Otherwise, they will go down rabbit holes. So I created this squad of my different agents. So I give a request and it goes into a consultant. And that consultant then farms it off using a fan-out pattern to multiple other different agents. And those agents they do data modeling, UX design, solution architecture, and they've all got skills. The agent defines the personality. So the data model is one of those typical DBA people that have no sense of humor. Apologies to any DBAs. But they're constrained. So the way that we start to reduce the neurodiversity in our agents is by constraining them, limiting how they actually behave, limiting the tools, limiting the skills. Now what it does then is after it's got all this information, it then fans back in and into a draft design. And then it sends it off to the critic. Now the critic is not trying to disrupt things much, little bit of disruption, but challenging all of the different suggestions, all the assumptions, challenging, and then if it finds anything, it sends it back off to the various different agents for them to address. And then once it's all resolved, you get the plan, sends it to the developer can start building things, and then it will go around that loop again. So it's an agentic loop with multiple different agents. So when I say, go cook, this is all going on. This is a multi-stage process with multiple different personalities and skills and tools. And the tester has access to a browser. Those of you that were in my workshop will have found out how to use a browser, how to give the agents browsers. They can go off to the website and they can test it. They can do usability studies, check that it's all working, it makes sense. So, I'm going to teach you very, 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 very quickly on how to do this yourself, because I want you to go away from here and start to build your own agents and your own skills. But first, actually, back to my confession. And my confession is, I've built agents for a lot of my friends. I've captured my friends in the essence and done things like given them access to AJ's Instagram stories and Sarah's LinkedIn feed and blog, and ask them to kind of learn as best as they possibly can how to act like those people. And so I can actually start to talk to my friends. So I can just say, hi, Sarah and Chris, can you help me come up with some ideas for the closing note of ColorCloud? And so what this does is it then farms it off to the various different agents.
Yes.
So basically what this is doing is it's demonstrating the different personas, and by constraining it, they can then have a conversation. So this is the fan out pattern. And then it will fan back in again, and then I can have a conversation. So I know that you all want me to carry on talking. Everyone wants to see what it's going to say. But you can come, maybe I'll let you have these agents at some point. But what I'm going to show you is how to do this yourself. How can you do this? Now, I'm in VS Code here. You could be using GitHub Copilot CLI, but you remember I said there's skills, right? You've got agents, which is the personality, and skills, which is the capability, the knowledge, and the details of how to do it. And you've got a lot of built-in skills. You've also got skills that I've added in. So I've got my own Power Platform skills. I've got a whole ton of them. I've got agents that know how to do my squad, my IT crowd, and then I've got skills that all those agents know how to, so they know how to do things like build databases and use MCP servers. But there is a really cool skill, which is create agent. So I can say create agent, so go research my skip manager profile and writing, Donna Sarkar, because she's not here, so we can do that, and create an agent as close to act as close as her. So you do that, and it would now go off, and it will use all the tools that I've given it to. And once you've created that agent, it's then available in your agent picker, so you can start to interact with it. So I've got all these. These are my squad agents here, and my community. I'm not going to start to show you who I've got in my community, my friends there. But suffice to say, there's quite a lot of them. But also, next thing for you to try. This is in true Donna style. I'm sure the Donna agent would be giving you the same thing. Is homework. Donna always gives you homework. Right, so this is your homework. So now, also, as well as the create agent, use create skill. So you can now start to say, I don't know, let's create a skill. How do we track where AJ is on a night out in Hamburg? So, yeah, you can see where this is going, right? So that is your homework. Go away from there, start to create skills, and start to create agents. So, This was the keynote last year. This was Donna, got a load of people up from the community. And Anna, see, you are in the keynote. So this would never, ever be suggested by my squad of agents. It would never come up with something as original as this. It would require me to work with these agents, to provide something, some I don't know, glitter muffins, as Chris would probably call it. And the reason that is, and this was another one of my rabbit holes, I've been watching a lot of lectures on psychology and philosophy recently. And it's really interesting because knowledge, we talk about knowledge with agents, right? We've seen Copilot Studio, at Foundry, we give knowledge. But knowledge is split into two types of knowledge. There is explicit knowledge and tacit knowledge. Explicit knowledge is the knowledge that you can codify. It's the knowledge that you can write down, the stuff that you've learned, the things that you've experienced, and you can write it down explicitly. Tacit knowledge is the stuff that you know and you've experienced, but you can't codify. Now, what's interesting is that in explicit knowledge, there are echoes of tacit knowledge. There are echoes. So that is why when we see my community friends talking, it kind of you go, huh, looks like they're kind of like, yeah, they're talking. It feels like it's kind of a human conversation. Well, as human as my friends get. And so, but it's not actually tacit knowledge. In order to come up with an idea like Donna came up with for that crazy keynote, that needs Donna's tacit knowledge. And an agent is never going to be able to have a tacit knowledge. Why? Because in order to get tacit knowledge, you need to be able to experience things. And fundamentally, agents can't experience things. Why it matters. This is AI generated, of course. Because AI agents are always telling us why it matters, right? Yes? How many times have you seen that? Why LinkedIn posts, you scroll down, there it is, staring you in the face. Why it matters. You ask it to create you a Word document, scroll down, there it is. Why it matters. AI is constantly trying to justify itself, showing it's working. Oh, why does it matter? Why am I telling you this? Because I'm trying to justify why I'm really good. And so, but it's kind of like, you know, an expectations versus reality kind of thing. Because it's telling us why it matters, but if you look at it so many times, it's all explicit knowledge stuff. There is no tacit knowledge there. It just misses the point so many times. It misses that human why it matters. So I have another confession. I don't write code anymore. What I'm doing all the time is I'm trying my best, trying my hardest to codify my tacit knowledge and put it into explicit knowledge. I'm pushing the boundaries of what I can do in skills and agents. I know I'm never going to get there, but I'm pushing the boundaries. I'm trying to get good at creating these agents, creating these skills, in order to push the boundaries so I can make my explicit knowledge and give it to my agents to make it work as best as possible. Sarah came to my workshop a couple of days ago saying, do I need developers? And I gave Sarah my agents and my skills. It was all the explicit knowledge. It's got echoes of my tacit knowledge. So there's some of me in there, but it's certainly, I promise you, it's not actually me in there. You still probably are gonna need me to ask me for my tacit knowledge. So, to the pro devs in the audience, don't let anyone say, AI writes code, no one needs you. I don't write code. And so, who needs me? But actually, I've got one very simple thing to ask you to do. It's to use your tacit knowledge, your experience, to improve the developer experience, the DevX. Because the developer experience is the thing that enables you to open up a desktop, start working on some code. Clone a repo, create an environment, have all the necessary logins, make sure you've got access to the right databases very, very quickly, so you can solve that bug or you can create that feature. That's the developer experience. Make that developer experience the best you can, because if you can make that developer experience the best you can, because it needs your experience to understand how that works, the AI agents are going to have a better experience and they're going to be more efficient. So apply your tacit knowledge to create that explicit knowledge and developer experience. So, and to all the makers and builders, don't let anybody tell you that because you don't understand TypeScript or C# or something like that, that actually you no longer need it, okay? Because the stuff that you've been doing for many, many years in all the different businesses you work in, all the different companies, all the things that you've learned, that experience, the day-to-day, the understanding the priorities, understanding what is important, when actually something is ready to deploy, when something is ready to publish, that experience, that is worth gold. And that is the thing that AI will never be able to do, because it's your tacit knowledge. So I'm not asking you to learn to code. I'm certainly not asking you to learn to prompt harder. What I'm asking you to do is go and do that and share it, so that other people can then benefit from it as well. Other people can benefit from your explicit knowledge, which is then an echo of your tacit knowledge. And that is going to make us be able to do so much more together, working together. You can create agents and skills in GitHub Copilot, like I showed you. If you're using M365 CoWork, you can create skills in M365 CoWork. You can now create Dataverse business skills that can then be accessed through WorkIQ, and they all have exactly the same structure, that codified explicit knowledge. So in the hotel room, on the wallpaper, if you're staying in the 25 hotel, you might notice that it says "Always be curious," and I think this is what always strikes me as the thing that really defines how we work now. It's being a little bit ADHD. It doesn't matter if you are neurodivergent, if you are neurotypical, if you are in business, or if you're in the technical side of things. We need people like Jack in Mission Control that have that tacit knowledge, the deep understanding of how things work, to be able to make there be a zero chance of astronaut death. Now, Jamie got a pay rise. So it turns out that actually, yeah, he can drive a digger. But it's events like this that just demonstrate that whether or not you are vocational, your technology, using technology, logic mind, it's events like this where we all come together. If you ask anybody, any technologist, you say, can we get rid of the people that manage all the business process and do all of the business analyst stuff? I can guarantee you that those technical people will say, with an analytical mind, logical mind, will say, absolutely not. And if you ask the business people, the people who are doing all of this, the softer stuff to do with business, if you ask them, can we get rid of the people with the analytical, logical minds that used to be the coders, I can guarantee you that they will tell you they can't do without them, because we need the full spectrum. And that's what's so amazing about ColorCloud, is that we have this full spectrum of people all coming together, neurodiversity or otherwise, all coming together and collaborating. And I am optimistic. It's events like this that really bring such a sense of gratitude to know all of the different people I know in the community, all the different types of brains, the DNAs, all the different DNAs that come together, this rich spectrum, this rich tapestry. I'm optimistic that in this amazing place, in this amazing city, Hamburg, in this amazing country, in this amazing world, we truly have a magical and special world, and also universe that we can go and explore through space flight. I'm optimistic that by events like this, by you being here, we really will be able to create an amazing future. So, you have to decide why it matters. Don't let the AI tell you why it matters. You get to decide that. So, all that remains is for me to give you these QR codes. If you want to go and learn more about all of the cool stuff that my team does, and also, what do I have to tell you now?
Party. Cook. Party.
Party.
Louder?
Party!
Party! Thank you so much for listening, and have a great evening.